We are going to discuss more on porosity in the introductory stage. Take note that porosity is very important to petroleum engineering and petroleum industries. That's why it's advisable for a petroleum engineer to understand more about porosity. Porosity measures the storage capacity of reservoir rock, and also porosity is classified by two ways. We have the origin of the rock, and we also have by measures of its pore connectivities. Now we start with by rock origin. Now under rock origin is classified into primary and secondary. By rock origin, the first category is primary form. They are formed by erosion. Diagram B explains everything you need to know about the sediment deposition. But by further explanation, let's say after decomposition of dead plants and animals, various forms of erosions which are caused by the wind, rainfall, stream flows, and so on helps to transport these decomposed matters to the river, sea, lake, and others. After it's been transported to the water, it settles at a spot. That spot is what we call sediment decomposition. It keeps multiplying and increasing in volumes, compressing each other, and other phenomena like temperature and pressures. Then cementation to form a sediment rock. Okay. In the secondary form, they are formed as a result of saturated activities within the earth crust geological process such as faulting, fractures, and folds. What really caused this geological process are disasters like erosion, strong erosion, earthquakes, eruption, and others. Now for faulting, let's talk about faulting. Faulting, just imagine using a knife to cut a full loaf of bread. Full loaf of bread. With that scenario, that's how it's being cut naturally, thereby causing crude oil traps. You can check on my videos for crude oil traps to know more on description. Folding is like folding a piece of paper with your hands. You will notice that the paper you fold did not break, no matter how much strength you apply. It's just there the way you fold it. With that simple scenario, that's how folding occurs naturally. Now, for the next diagram is fracture. For fracture, let me say it's like squeezing a lot of biscuits with your hands, as your hands can cover. It's obvious that there will be breaks on the biscuits. That's how it occurs naturally by fracture. Part B, by measures of pore connectivity, is categorized into two forms. One, we have the total or absolute porosity, and two, we have the effective porosity. Let's talk about the total porosity. Total porosity is the total number of void or pore spaces within that rock, regardless of its interconnected pore space. While for effective porosity is that portion of total void space of a porous material that is capable of transmitting a fluid. Let's say we have a sample like this image. Total space is the total porosity, while the ability for the fluid to flow through the sample is called effective porosity. All rock samples are porous, but not all rock grains allow fluid or water to flow freely. The hypothesis stage. Experiment determination of a rock porosity could be carried out using several methods, and these several methods of determining porosity is grouped into three forms, which are the well testing method, the well logging techniques, and core analysis. Now, let me briefly explain these three before we go further. For well testing method is used to interpret actual testing data. That is, they take the fluid sample or drill cuttings to the lab to get the test data. There are so many test data. So in this test data, porosity is one of them. Now let me talk about the core analysis because it relates with the well testing method. Now for the core analysis, core samples are small portion of formation taken from an existing well and used for geologic analysis. These analyses are porosity, permeability, rock age, and so on. I also prepared a video about that if you want to know more. Core analysis work along with well testing, and without well testing you can't get core analysis, and without core analysis there won't be result for well testing because there must be a core sample. The relationship between these two, core analysis and well testing, is that well testing increase the knowledge and understanding of hydrocarbon properties. For well logging, in simplified terms, is a process of making a detailed record of penetration. For instance, let's say how much depth can you drill from the surface to the reservoir rock. Now under core analysis, we are going to be using a method of experiment, which is the liquid saturation method. In this method, a dry sample is weighed, then saturated with fluid of unknown density. In this experiment, we use water, which has a density of 1 gram per cm cube. After saturation for a period of time like 1 hour, is then weighed again. Now to get the pore volume, you have to find the difference between the soaked weight and the dried weight, or let me say the soaked weight minus the dried weight. Take note, for sensitive samples, oil could be used for pore saturation. Equipment and apparatus. We make use of heat oven. Heat oven helps to dry the core samples. Next is water bowl. In the bowl is where the samples will be soaked with water. Next is electric weighing balance. Is used to measure the weight. We have the stopwatch. Is used to record time of your sample during saturation. We have the meter or calipers. Is used for taking sample dimensions. The tongue for holding and carrying core samples. We have the core sample itself. There are the formation sample to be tested in the lab. For procedure, we measure the height and diameter of the core sample. Sample A is sand and cement, while sample B is mud and cement. We have to take their various weights when it's dried and after it's being soaked in water. Then calculate the effective porosity.
Yes. 109. I'm what? I'm on. What the? Boy, look at that. 0.21.
Number 1. We ensure that the samples was properly dried before used. Number 2. We ensure that the fans are switched off to avoid interference by the surrounding. Number 3. The samples are allowed to completely saturate, that is, left in water for a minimum of 1 hour to have accurate pore volume and pore values. And lastly, we make sure that the density of the fluid is known. In this experiment, we are using water, and water is 1 gram per cm cube. You can also use other fluid like oil base, but you have to still know their various densities. These are results we got during the lab experiment, and it is listed down in the results stage. Now, for sample A, the weight when it was dried was 75.24 gram. I call it W dry, meaning weight when dried. And the next one is W sat, which means the weight after saturation or after being soaked in water. In this result stage, I will use W dry and W sat to represent each of them, so don't be confused. Next, we have density of the fluid, which is water and is 1 gram per cm cube. The core length is the pipe length which the sample was into. Lastly is the core diameter, that is the pipe diameter. We can use any material with different shape. If it is a square shape or pipe, for instance, it's going to be length times breadth. If it is a triangle, it's going to be 1.5 base times height, and so on. The mathematical data are easily understandable if you want to study through, but our result is 23% of effective porosity. Sample B. Follow the same process of calculation. You will notice that sample B has the highest portion of porosity, which is 31%. Discussion and observations. In this stage, we have to list our observations of the practical experiment we have done and explain more concerning the experiment. Now, 2 different samples were used and grouped A and B. We notice that after the samples were saturated, their pore volume and effective porosity are not the same. Therefore, we can say sample B has the highest transmission or flow or effective porosity. Now let me brief a point to you. The increase and decrease in percentage of effective porosity has its own disadvantage and advantage depending on their applications. Okay, let's see. For the high effective porosity, it helps for the transmission of fluid flow to the reservoir rock. Fluid can be oil, water or gas because they are all located in the reservoir. For low effective porosity, it helps for cementation of wellbore body, which they cause casing, so it will prevent the fluid from escaping to various rock formations. I believe you have seen a mason plastering a wall in the site. They mix cement, sand and water. That's how it's being done in the wellbore. Now for the reference, you have to list out your research dates and the places where practicals have been done. So let me give you a bonus. Make sure you attend SPE in case you haven't been attending XPE. because it's a platform where you freely ask any question you want, and professionals will give you answer you deserve in the best way because they have experience on the feed. So try and register for XPE, and don't forget to like, subscribe, and share this video to motivate me for more videos.